Okay, so in this video, what we're going to do is talk about our geometric relationships. And we have a lot of different types of geometric relationships. Okay, so one of the first things that we should talk about is naming parts of geometric figures. Okay, so there's a lot of writing on here. You don't have to copy everything down. I'll highlight or underline important things. Okay, so the first thing that I want you guys to copy down is this lovely picture. And I want you to notice that there are points on what appears to be a line. So we see D, we see J, we see E. So anytime we have a point, right, we want to make sure that we use a capital letter. Okay, so that's really important. Okay, now we have different types of lines and line segments. So a line does go off in, it goes off infinitely in two directions, okay? And I can call the line by different names that are points on the line. So when I want to talk about a line, okay, what I want to do is I want to use two of these letters, and the order doesn't matter of the letters. So I can say that it's D and J, so DJ, but I want to indicate that it's a line. So what I'm going to do is I'm going to draw a little line above those letters, right? So I can say D and J. I can also say E, D. Again, I can draw a little line above those letters, okay? Now, there is a difference between the word line and the word line segment. So a line segment has what we call endpoints. Okay, so that means it's a start and stop. Okay, so if I want to just look at D to J, I'm only looking between these two bars. And so a line segment, right, just means that, again, we take two letters, it doesn't matter the order of those two letters, and we put a little line segment up above, right? So D to J or J to D means the same exact thing, right? So we can say both of those. So the order really doesn't matter for both of these. So order of letters doesn't matter for line and line segment. Okay. Now, something that does matter is something known as a ray. Okay. So let's go ahead and copy down this lovely picture. Okay. And what a ray is, it's just part of a line that starts at one point and extends in one direction. So you can go ahead and you can copy that sentence down. Okay. But this is important. The order does matter. When naming rays, the endpoint must always come first. Okay, so that is really important. So when I talk about the rays on this picture, okay, I want to address them as G ends up being my vertex, right, my starting point or end point, so to speak, right? So I'm going to start with G, and then I'm going to go to F. I now know, and again, I'm going to draw a little ray above it, I now know where I am. It's this little ray right here. So that guy is that. Okay. If I want to draw G to H, right, with my little ray, change my color up, my G to H would be this guy right here. Okay. So again, the order matters for rays. It does not matter um, for line segments and lines. Okay. Now, when you connect two rays together, so when we connect the GF and the GH together, they form what's known as an angle. So let's go ahead, come over here, and an angle is formed by two rays joined at the endpoints. Okay. Now, for angles, okay, we can label them in two ways. We can either label them with a single letter, so angle A would be this picture right here, or we can name them with 3 points, with the center point being the vertex. Okay, so the reason why we want to do this, right, is because sometimes we don't know what angle we're talking about. Okay, so for instance, that last picture, let me redraw it over here. So I believe this was G, we had an F, and we had, I think it was an H, yeah, and then there's an I, so H and I, so we can use the same thing. So when I ask you about angle G, right, I usually don't put that little half part right here. I usually don't put that, so I just put this. I don't actually know what I'm talking about. Am I talking about this piece right here? Am I talking about this piece right here? Am I talking about all of this? I don't know. So we want to try to be specific, right? So single letter is when it's perfectly clear that I know exactly where I'm talking about. Okay, so angle A, I know that it's this piece right here. But for a problem like this, I don't know. So I want to use my 3 letters. G would be in the middle. So I don't want to necessarily use this for this picture. So if I want to talk about this angle in here, I'm going to use 3 letters. And it doesn't matter if you say F first and H first, but the G has to go in the middle, right? So you really want to use 3 letters when you don't know which angle you're talking about. Now, we have a lot of different types of angles that we can address. Okay, one of the first types of angles that we can talk about is something known as adjacent angles. So go ahead and copy this down. Adjacent angles are side by side and they share a common ray. Right? So in here, my adjacent angle is 45 and 15. You can see that the orange line, right, is that common ray. Okay, so make sure that you at least have one picture copy down for adjacent angles. And again, at any point, please pause the video to copy everything down. Now, here are some examples of more adjacent angles. You don't need to copy them down, right, unless you want to. So don't need to copy. So notice that 35 and 55, those are my 2 angles. They share a common ray. 85 and 20, we see that purple as our ray. 130 and 150, again, common ray. So they are right next to each other. Okay? These angles are not adjacent. So again, no need to copy. So no need to copy. So notice that 100 degrees and 50 degrees, they look like they're right next to each other, but they're not sharing the same angle. Okay, 55 and 145, they're on the same line, right? But again, they're not sharing the same angle. And 35 and 35, they're right across from each other. So again, these are examples that are not adjacent. Okay, so adjacent is kind of like the overarching umbrella of angles. Now we have very specific types of adjacent angles that we want to talk about. And these two can be found over here. Okay. So I would like you to please copy down this. 2 angles whose measurements have a sum of 90 degrees are called complementary angles. Okay. And you can copy down this picture right here as well. Now, these angles, right, are going to be adjacent angles. I'm going to abbreviate adjacent to ADJ. So they are right next to each other. So what this is saying, right, in this picture, we know it's 90 degrees because it has this little marking right here. So again, markings are very important. And so again, I don't know where I'm talking about for angle B. So this would be a good example of where I'd want to use 3 letters. So I'm going to say angle A, B, C. So I'm talking about this guy right here, plus my angle C, B, D. Now talking about that angle right here, I can make this equal to 90 degrees. Now, 90 degrees does have an angle that we can call it, and that angle for 90 degrees would be A, B, and D. Now, the great thing about this is that if you actually know what one of your angles is, you can find your other angle, okay? So let's go ahead and answer this question. So if I know that measurement angle CBD is equal to 75, anytime you see that little M, that just stands for measurement. It just says that we have an actual number. So I get to replace CBD with 76. So just angle ABC plus 76 is equal to 90. We can easily subtract 76 degrees to both sides, and I'm going to get that ABC is equal to 14 degrees. Okay, now technically this is a measurement, so we should put the little m next to it. If we forget, not too big of a deal. Now, 90 degrees are complementary angles. When they add up to 180, they're known as supplementary angles. So go ahead now, copy this down, and you can copy this new picture down. Okay. So again, what angle am I talking about when I say angle M? I don't know. So I want to use 3 letters. So I'm going to say angle LMP. So LMP is right here. I can add that to angle PMN. So now I'm talking about that angle right here. Together, they form 180. So 180. So again, this can, 180 also has another angle. It's all on the same line, LMN. Now, when something is on the same line, they actually have a very specific name. So LMN can sometimes be called a straight angle pair or a linear pair, right? Because there's a pair because it's 2 of them, right? If it's more on the same line, you can say, instead of a pair, you can say a triple. Okay. Again, if we know what one of the angles are, we can solve for the other one. Okay. So let's try this one. If we know, let me put it back in here. So if we know that the measurement of LMP is 62, this would be like saying 62 degrees plus our unknown measurement is equal to 180. I will subtract 62 degrees, and when I do, I get my angle PMN is equal to 118. Again, this is a measurement, so we should put the letter M in there. All right, so adjacent, we can have 2 very specific types of angles, complementary and supplementary. What other types of angles can we have? Well, we can have vertical angles. So let's talk about those. So when lines intersect, the angles that lie on opposite sides of that intersection are called vertical angles. Okay, so here's our lovely vertical angles. Okay, disregard that there's a little X right here, so cross this off for right now. And go ahead and copy this picture down as well. Okay. So sometimes instead of using letters, right, we can actually also use numbers. So I'm going to renumber these, and I'm going to say 1, 2, 3, and 4. So I'm talking about those angles right there. So a pair of vertical angles, so vertical angles, 1, so angle 1, and angle 3 are across from each other. Angle 4 and angle 2 are also across from each other. So those would be pairs of vertical angles if we don't want to use those 3 letters. Okay, Now, the great thing is that once you actually know one of these angles, you can find out the other three. So let's pretend that angle 1, measurement of angle 1 was, say, equal to 20 degrees, right? I want to find the rest of my angle measurements. Well, what do I know? I know that 1 and 2 are on the same line, right? So angle 1 plus angle 2, that should equal 180. I now know that that's 20 degrees. So I can go ahead and I can subtract, and this will give me 160. So I have a measurement of angle 2. So again, this is 20 degrees now. This is 160. Okay, and I can continue to do this. 2 and 3, angle 2 plus angle 3 also equals 180, but I know what angle 2 is. It's 160. And notice that angle 3 is 20 degrees. Interesting. My 1 and 3, which are vertical angles, right, are actually the same number. All right, well, let's test out 1 and 4, right? So 1 plus angle 4 should also equal 180. I know angle 1 is 20 degrees. And I've already seen this problem out before, right up here. So that means angle 4 is 160. So again, notice that 160 and 160, they're across from each other. Whenever angles have the same measurement or line segments have the same measurement, we can call them congruent angles. So go ahead, copy that down. And we do have a congruent symbol. So the congruent symbol looks like this, a little equal sign, and a squiggle. Okay, so based on this information, what I want you to do is I want you to write a conjecture. So a conjecture is just a statement based on an incomplete evidence that's unproven. So think of it almost like a hypothesis, right? You're kind of guessing, what do we think? So again, you can pause the video, try to write your own conjecture. It is okay to be wrong. A lot of people are wrong when they create a hypothesis because we have to test it, see if we're true. All right, so a good hypothesis for this might be that vertical angles are congruent. That is a good hypothesis. Okay, so how can I tell if these vertical angles are congruent? I need to prove that this is true. Okay, now I don't want to prove it with numbers because it just happened to work with 20 and 160. Will it work for every single number out there? I don't know. So I don't necessarily want to replace my angles with numbers. So what should I do? All right, so I'm going to clean this picture up over here, and I'm going to copy this down. So here's our proof. Okay, so our proof, we're trying to prove that B is going to equal C because these are vertical angles. That's what we're going to try to prove. So prove this. All right, so what do I know? Well, I know that angle A and C together are on the same line. So A plus C should equal 180. Okay. I also know that A and B are also on the same line. So I know that A plus B is also equal to 180. Notice that both the equations that I wrote have 180. They also have the letter A in it too, but they both have 180 in it. So what I'm going to do is I'm going to use my system of equations, and I'm going to say that A plus C is equal to A plus B. All right, so I took away the 180s. Now notice that my A's, if I subtract A from both sides, notice what I get. C is equal to B. And that's exactly what we wanted to prove right there. Once we have proven something to be true, we no longer have to call it a conjecture, we get to call it a theorem. So once a conjecture is proven to be true, it is now a theorem. So what we wrote out originally, we said vertical angles are congruent, right, as our conjecture. So now what I want you to write down is I just want you to write down that this is actually now our theorem. All right. So what else can we have, right? What other types of angles? Well, the rest of the angles are going to be made by something known as a transversal line. So a transversal, what I want you guys to do is I want you to copy down the word transversal and the definition. All right, so transversal is a line, a ray, or a segment that intersects two or more lines, rays, and segments. So, and then here is our first example. We have two sets of parallel lines. We have a transversal that's cutting it. You don't need to necessarily copy down the word exterior, interior, and stuff like that. And then here's an example of non-parallel lines. So again, we can have two lines and they can still be cut by the transversal. Okay, and again, you have exterior because they're on the outside and interior. So I do want you to copy down the pictures, but you don't need to copy down what is starred unless you want to. Okay, because again, people think that, oh, your lines have to be parallel in order to have a transversal line. We don't. Okay, we can have non-parallel, but parallel lines are going to be important. Okay. Now, what does it really mean by interior and exterior? Okay. So with that being said, interior just is the space inside the two lines. Exterior is the outside is the space outside of the two lines. So go ahead and copy that information down. If you want to copy the picture down too, you can, but you do not have to. Okay. So we're on to the last kind of sets of angles. So we have what's known as corresponding angles. So corresponding angles are two angles that occupy corresponding positions. So go ahead, copy this down. They are congruent, aka equal, if the transversal line cuts two parallel lines. Notice that the picture, and do copy the picture down. You only need to copy it down once because we'll be referring back to this picture a couple times. Notice that this picture does not have parallel lines, but our angles are still in the same position, right? So notice that 1 and 5 are color coordinated because they're above the line and to the left of the transversal, right? So corresponding angles, right? Angle 1 and angle 5, they go together, right? Angle 2 goes with angle 6, notice they're on the right. Angle 3 and angle 7, and finally angle 4 and angle 8. Now for our sake, we will put some parallel lines. We'll make them parallel, so we will say that they are congruent. Okay, so corresponding angles occupy the same place. Okay, so I want you guys to notice that once I give you one angle, right, you can actually find all the other angles. So see, I said that angle 1 was 40 degrees. Well, using my vertical angles, I know that 4 is also 40 degrees. If I use supplementary angles, right, I know that 2 should be 140 degrees because these two are 180, which means 3 is also 140. Since I did put this symbol in as parallel, now I know that 40 matches up with 5, so that means that that's 40. The 3 matches up for sure with the 7, so that gives you 140. So notice that I just gave you this one to begin with, and you can figure out all of the rest of them. If they were not parallel, we'd only be able to figure out 1 through 4. If I just gave you 1, I'd have to give you other information. Okay, but notice that there's a lot of the same angles. So notice that like 4 and 5 are the same. Notice that like 3 and 6 are the same. So they also have specific names. And those specific names are known, one of them, as alternate interior angles and alternate exterior angles. Okay, so alternate, so go ahead, copy that down. Copy that down. So alternate interior angles are two angles that lie between parallel lines on opposite sides of the transversal, but again, they're not linear pair. The second we add the word parallel, that means that they are congruent. And same thing for alternate exterior angles. Again, they are congruent. So alternate interior angles would be angle 3 and angle 6. So those are alternate. Alternate meaning they're on opposite sides of the transversal. Interior because they're on the inside of your lines. Okay, 4 and 5, notice again, they're color coordinated. So 4 and 5 would also be in that same box. Okay, on this one, exterior, so that means they're on the outside. So 1 and 8, notice that they are color coordinated. And 2 and angle 7 are also coordinated. So those are both alternate interior angles. Okay, so the last type of angles that we are going to see is something known as same side angles. So same side angles are this. That means that they are the same side of your transversal and they're inside your lines. So go ahead, copy this down. And again, if they lie between the keyword parallel lines, then what this means is that they are supplementary angles. And same thing on this one, they are supplementary. Okay, so if they're on the same side interior, 4 and 6 would go together. So this would be considered the same side. 3 and 5 are considered same side interior. On outside, 1 and 7 go together, and 2 and angle 8 go together. So those are considered same side. So again, same side meaning they're on the exact same side of the transversal, but they're on the outside of our parallel lines or on the inside of our parallel lines. Okay, now they don't have to necessarily be parallel. If they are parallel, we just get to add this information. If they're not parallel, then they have no other distincting values. Just like alternate interior angles, if they are not between parallel lines, we can't actually say that they are congruent. Okay, now just to recap, you don't have to copy this slide down. This is just a recap of what we kind of just talked about a little bit. So recap, don't copy. Don't copy. If parallel lines are cut by a transversal, then the following pairs of angles are congruent, right? Are corresponding, are alternate, are interior. If the parallel lines are cut by a transversal, the following are supplementary, meaning that they add to 180. Okay, so we get same side interior and exterior. All right, so now using all of our information, I want you to try one practice problem. And I want you to pause the video. I want you to try to come up with all of these angles first and then see how well you do. Okay, so here is our practice problem. Finding all the measurement. You don't have to worry about naming the theorem as long as in your head you know. The word postulate is just another fancy name for theorem. Okay, so go ahead and I want you to try to find angle 1, 2, 3, 4, 5, and then 6, 7, 8, and over here 9, 10, 11, and 12. Okay, I will be finding the angles in 3, 2, 1. Okay, so hopefully you paused the video and you tried to find these on your own. Okay, so I'm going to start off with what I think is the easiest. I'm going to start off with 120. So 120 is across from 7. So I know that this angle should have also been 120. Now, I know that 6 and 120 are on the same line, so these should add up to 180. So I'm going to subtract 120 from 180, and I will get 60. 60 is across from 8, so that means that this is also 60 degrees. Up on top, I can't answer anything for 9, 10, 11, and 12 because these two lines are not parallel to each other. But up at top, I do know that angle 3 is going to be 40 degrees. Okay? What else do I know? Well, I know that 4 and 7 are on the same side and they're interior, so 4 and 7 should add up to 180, which means that that should be 60 degrees. Now, this one's a little trickier. I can do it a couple different ways. I know that this guy right here, let me change my color really fast. I know that angle 7 is in the same position as 40 plus 5. So what I could do is I could say 20 is equal to 40 plus angle 5, right? Subtract my 40 from both sides, and I will get angle 5 is equal to 80 degrees. Now, if you think about it, oops, can't really see that 80 degrees right there. Now, 40 plus 80 plus 60, all of this will give me 180. Now, once I know 5, I also know 2. Once I know 4, I also know 60 as angle 1. All right, what else do I know? Okay, I know that, let's see, angle 2 is in the same position as angle 12. So that means that this is also 80 degrees, which means if I know 12, I know 10. And if I know 10, I actually know 9 and 11 because this right here is 180. So if I subtract 80 from 180, I get 100 degrees. And again, this is 100 degrees right here. And this guy right here corresponds to this guy right here. So again, a lot of different ways that we can figure out. These were just my strategies to find my angles. If you have any questions or concerns, feel free to reach out.